Corresponding parts of congruent figures are congruent. Explain congruence of parts of transformed figures. You will investigate some conclusions you can make when you know that two figures are congruent. A. Fold a sheet of paper in half. Use a straight edge to draw a triangle on the folded sheet, then cut out the triangle, cutting through both layers of paper to produce two congruent triangles. Label them ABC and DEF as shown. Place the triangles next to each other on a desktop. Since the triangles are congruent, there must be a sequence of rigid motions that map triangle ABC to triangle DEF. Describe the sequence of rigid motions. In the image shown, the sequence of rigid motions would just be a translation down and to the right, but if you had these on a desktop, it could require a translation, a rotation, or a reflection, or the combination of all of them. The same sequence of rigid motions that maps triangle ABC to triangle DEF maps parts of triangle ABC to parts of triangle DEF. Complete the following. AB corresponds to DE. Side BC corresponds to side EF. Side AC corresponds to side DF. Point A corresponds to point D. Point B corresponds to point E. And point C corresponds to point F. What does step C tell you about the corresponding parts of the two triangles? Why? The corresponding parts are congruent. Since they can be mapped onto one another. If you know that triangle ABC is congruent to triangle DEF, what 6 congruent statements about the segments and angles can you write? Why? We can write 3 congruences between the sets of sides and 3 congruences between the sets of angles because the rigid motions that map the triangles together also map the sides and angles together. Do your findings in this Explorer apply to figures other than triangles? For instance, if you know that quadrilaterals JKLM and PQRS are congruent, can you make any conclusions about corresponding parts? Why or why not? Yes, because the quadrilaterals are congruent, there has to be a sequence of rigid motions that map them to each other. Therefore, the sides and angles are also mapped to each other. Corresponding parts of congruent figures are congruent. The following true statement summarizes what you discovered in the Explorer. If two figures are congruent, then corresponding sides are congruent and corresponding angles are congruent. Example 1. Triangle ABC is congruent to triangle DEF. Find the given side length or angle measure. A. DE. Find the side that corresponds to DE. Since triangle ABC is congruent to triangle DEF, side AB is congruent to side DE. Find the unknown length. DE is equal to AB. Since AB is 2.6 centimeters, DE must also be 2.6 centimeters. B. The measure of angle B. Find the angle that corresponds to angle B. Since triangle ABC is congruent to triangle DEF, angle B is congruent to angle E. B is the middle letter and E is the middle letter, so those ones get paired together, meaning the measure of angle B is the same as the measure of angle E. E is 65 degrees, so B is also 65 degrees. The triangles shown in the figure are congruent. Can you conclude that JK is congruent to QR? Explain. No, the segments appear to be congruent, but the correspondence is not given, so we can't assume JK and QR are the corresponding parts. It may be that JK and PR are the parts that correspond. Since it doesn't tell us that JKL corresponds with QRP, we don't know which points match up with which. Triangle STU is congruent to triangle VWX. Find the given side length or angle measure. SU, that is the first and last letter, so it's going to match up with VX. VX is 43 feet, so SU must also equal 43 feet. 5. The measure of angle S. S matches up with V, and V is 38 degrees, so the measure of angle S must also be 38 degrees. Applying the properties of congruence. Rigid motions preserve length and angle measure. This means that congruent segments have the same length, so side UV is congruent to side XY, implies that they are equal, and vice versa. In the same way, congruent angles have the same measure, so angle J is congruent to angle K, implies that their measures are equal, and vice versa. Here are some properties. The reflexive property of congruence says that side AB is the same as side AB. This is also true for angles, so it could say angle A is congruent to angle A. Basically, if they're overlapping or touching or using the same piece, they are the same. There is a typo for the symmetric property of congruence. It should say if AB is congruent to CD, then CD is congruent to AB, meaning it works both ways. If 5 is equal to 2 plus 3, 2 plus 3 is also equal to 5. The transitive property of congruence says if AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. Let me give you an example. Let's use some numbers. If 4 plus 2 is 6, and that's equal to 3 plus 3, and 3 plus 3 is equal to 5 plus 1, then our original statement 4 plus 2 must be equal to our new statement 5 plus 1 because there is this overlap here. What's happening is they say, okay, well, these things are both equal to CD, so then they must be the same as each other. Example 2. Triangle ABC is congruent to triangle DEF. Find the given side length or angle measure. AB. Since triangle AB is congruent to DEF, AB is congruent to DE, the first two letters. Therefore, they are equal. That means AB and DE must be equal. So they've taken the two algebraic expressions and turned them into an equation. 3x plus 8 must equal 5x. Then they subtract 3x from both sides, leaving us with 8 equals 2x. Divide both sides by 2, and you get x equals 4. But that doesn't tell us what the side AB is equal to. We then have to go and plug it back in. If x is 4, 3 times 4 is 12, plus 8 equals 20. We're still using the diagram from the previous page, so if you need to flip back and forth, you can. I don't have it in front of me, but I'm going to reference that picture from part A. It says the measure of angle D. Since ABC is congruent to DEF, then A is congruent to D because they are both mentioned first. That's why I said in number 3 that we need that triangle correspondence to be able to tell which parts are corresponding to one another. Therefore, the measure of angle A must equal the measure of angle D. In the diagram on part A from page 911, we have that A is 5y plus 11, and angle D says 6y plus 2. Then they subtract 5y from both sides, so we're left with a single y. They subtract 2 from both sides, so we're left with 9. And then to solve it for the angle, we have to plug it back in. 6 times 9 plus 2. Well, 6 times 9 is 54, plus 2 is 56. Quadrilateral GHJK is congruent to quadrilateral LMNP. Find the given side length or angle measure. In number 6, we are looking for LM. LM is the first 2 letters, so it corresponds to GH. And GH is described by this expression. And LM is described by this expression. Now we need to do algebra to solve it for x. But we're not finished. We need to plug 8 back in to finish solving for the side length. So it is 35 centimeters. Now in 7, we need to find the measure of angle H. H is the second thing, and M is the second thing. So we are going to write an expression for H and M. M and H. We have 9y plus 17 is equal to 11y minus 1. We're going to start by solving for y and then plugging it back in. So the measure of angle H is 98 degrees. Write each proof. Given triangle ABD is congruent to ACD, prove that D is the midpoint of BC. I like to think of these statement reasoning tables in the similar way of a CER, or a claim evidence reasoning. First, we're making a claim, and then we have to provide how we know it. So number 1, ABD is congruent to ACD. And the reason is it's given to us. It told us that at the very beginning. Then they make another claim and they say, well, then that means BD is congruent to CD. These two things here, BD is congruent to CD. And the way that they know that is because if you look at corresponding parts of the triangle, BD and CD are listed in the same position. And since those triangles are congruent, those pieces are congruent. So they've written corresponding parts of congruent figures are congruent. Then it says D is the midpoint of BC. And the reason that they know is because that's the definition of a midpoint. If those two pieces are equal, then the point in the middle is called the midpoint. In B, given quadrilateral JKLM is congruent to NPQR and angle J is congruent to angle K, prove that angle J is congruent to angle P. First, they start out by saying those two quadrilaterals are congruent. That was a given. And their second statement says angle J is congruent to angle K, which was also given to us in the problem. Then they said angle K is congruent to angle P. That wasn't explicitly stated, but because it's written as second and second in the order of the congruence, we know by corresponding parts of congruent figures are congruent. And then they claim that angle J is congruent to angle P. I noticed that K is mentioned here and here. So by connecting statement 2 and 3, we know that angle J must be congruent to angle P, and that is by what's called the transitive property, which we talked about on page 911. 8. Write each proof. Given triangle SVT is congruent to SWT, prove that ST bisects angle VSW. Now, draw in the table for the statement and reasons. Let's start with what we know. Triangle SVT is congruent to triangle SWT because that was given to us. We're trying to show that ST bisects the big angle. In order to do that, we need to show that this angle and this angle are the same. So let's start there. Angle VST is congruent to WST, and that's true because V is the second letter, S is the first, T is the last. W was the second letter, S was the first, and T is the last. So those are corresponding parts, which means they are congruent. And since those two angles are the same, we know ST bisects angle VSW. And that is by definition of an angle bisector, because it split it into two equal parts. Given quadrilateral ABCD is congruent to EFGH and AD is congruent to CD, prove that AD is congruent to GH. Again, we'll start by listing the givens. It may also be helpful to label the pieces we know. We were just told AD is the same as CD. But we know that CD and GH are the same by corresponding parts of congruent shapes. And CD is mentioned here twice. So by the transitive property, AD must be congruent to GH. And we have proven what we were asked to prove. 10. A student claims that any two congruent triangles must have the same perimeter. Do you agree? Explain. Well, if all three sets of sides are congruent, then if we add all three sides together, their perimeters must also be congruent. 11. If triangle PQR is a right triangle and PQR is congruent to XYZ, does triangle XYZ have to be a right triangle? Why or why not? Yes, since corresponding parts of congruent triangles are congruent, then the angle that is a right angle will be congruent to the other angle in triangle XYZ. So it does have to be a right triangle. 12. Suppose you know that pentagon ABCDE is congruent to pentagon FGHJK. How many additional congruent statements can you write using corresponding parts of the pentagons? Explain. Well, pentagons have 5 sides, so we can write 5 side congruences. And they also have 5 angles, so we can write 5 angle congruences.